Okay, so I was saying, okay, last time we considered this Legendre differential equation and we find the solution to this very differential equation, which we called those solutions correspond to two different roots. We call them as the solution to the Legendre differential equation, or we can also call them as a Legendre polynomial. Now, so today we are going to find out these Legendre polynomials from that very solution, which we have already obtained in the last lecture. Now, as you know, the solution to this Legendre differential equation is given by y is some c naught x raised to power m corresponding to the one of the root, that is r is equal to m, because we find out the two solution, one correspond to r equal to m, other correspond to r equal to minus m minus 1. So I am considering this one first. So it is x raised to power m minus some m into m minus 1 divided by 2 into 2m minus 1, then x raised to power m minus 2 plus m into m minus 1 into m minus 2 into m minus 3 divided by some 4 into 2 uh, 2m minus 1 2m minus 3, then x raised to power m minus 4 plus some other terms, right? So this is a solution which we have already found in the last lecture. So this is a solution correspond to one of the root r equal to m to this very differential equation, which we call as a Legendre differential equation. Now I will assume that if m is a positive constant, if m is a positive constant, or we can say that is a positive value, and we will let c0 be equal to some 1 3 5 so on into 2m minus 1 divided by m factorial. So this is, since this is a constant, so this will also be a constant and it will depend upon the value of a m. Since c0 is a constant, c0 is a constant and can have any constant value, so can have any constant value, right? Fine. So if that is the case, then I will write down the same solution in I will just substitute the value of the c naught in this, so you can write down. Okay, so when I will substitute the value of the c naught into this very equation, instead of y, I will represent this solution by, I will write it as a pmx. Pmx is nothing, it is just a solution. So since we consider this to be a Legendre polynomial, that's why I will call this solution as a Legendre polynomial. So then I will write down this pmx as, I will write down this as 1 3 5, right? 1 3 5. Okay, so it's 1 3 5 and so on up to 2m minus 1 divided by this m factorial. Then we have the x raised to power m minus m into m minus 1 divided by 2 into 2m minus 1 x raised to power m minus 2 plus some other terms. You can write this term also. Okay, now this particular series, this is a series, this is a series in the powers of x. Now this series actually is a terminating series. Terminating series means it will terminate for some values of m. So now it will depend upon whether your m is positive or negative. This value of m is sorry, this m is either odd or even. So now when m is even, you have to remember, when m is even, so when m is like 0 2 4 6 8 10 so on, the series contains m by 2 terms. There will be only m by 2 terms. Yani for example, if m is equal to 4, the series will contain 4 by 2, that is 2 terms, right? If m is 6, it will contain 3 terms, right? And the last term being, जो last term इसमें होगी, and the last term is being minus 1 raised to power m by 2, then some m into m minus 1 into m minus 2 so on up to 1 divided by 2 4 6 so on. Then up to m, and it will depend upon the value of m, then 2m minus 1 2m minus 3 so on up to 1. Right. So now this is the value which we can get from this. Now it will depend upon the value of m. Let us suppose m is equal to 4, so it will be minus 1 raised to power 2 m into, so this is 4 into 4 minus 1, 3 6 divided by 4 minus 2, that is 2, and we will just substitute here. We will get the number of the terms. How many जो last term इसमें होगी, the last term will be this term. Similarly, if n is odd, so this is from this very equation which we call as a Legendre polynomial. This is called as a Legendre polynomial. Again, now if m is odd, this was if m is odd, then series, जो ये series आपकी, then this series will contain, or I will say the ends up with 1 by 2 m minus 1 terms. So suppose m is 3. Suppose m is 3. So it will be 3 minus 1, that is 2 by 2, that is, so it will be, it will contain 1 terms. Now it will depend upon the value of m. M can take the values like 1, 3, 5, 7, so on, odd terms. And again the last term जिसमें होगी, the last term being it's minus 1 raised to power 1 by 2 into m minus 1, then m into m minus 1, so on, m minus 2, m minus 3, 3 into 2 divided by, because it will contain the odd terms, that's why I'm taking it up to only 2. Similarly here it will be 2, 4, 6, so on up to m minus 1, then 2m minus 1, 2m minus 3, and so on up to 2. So now these, so we will get, I will just generalize this. So I will just write down these two differential equations in one single form as how I will write down this equation as, okay, I will do that later on, but I will do that later, but फिलहाल मैं इसको जो मैंने अभी यहाँ पे लिखा था, this pmx, so this pmx is what we called as a, this pmx is called Legendre polynomial of first kind. Legendre polynomial of first kind. Okay, so you need to remember only this, which we have already obtained this solution. We have already obtained this solution for the Legendre differential equation, and then the solution corresponding to the differential equation r equal to m. That is what we call as a Legendre polynomial of first kind. Now this information is, it is when m is even, so we can just guess whether how many terms it will contain if m is even, and how it will end up with, ये जरा कोई मारिफत जरा अपना स्पीकर बंद करो. So how it will end up with this, how many terms will be there if I will have, the even terms, or if I have the odd terms, right? So I will write down that later on. So this is what we call as a Legendre polynomial of first kind. Similarly, we have again these Legendre polynomials of first kind are because very important, because they are, as I said, they are terminating, they terminate. Now similarly we can have the second this polynomial that is represented by qm minus 1. Since we know that we have r is equal to minus m minus 1, we call them as a Legendre polynomial of this second kind, and we represent them by qmx. Okay, so when with r is equal to minus m minus 1, because we know why from this r is equal to minus 1, it comes from the initial equation of this, the solution to the Legendre differential equation as the root. So if this is the root to your Legendre differential equation, then you know that this 1 minus x square y double prime minus 2xy prime, this Legendre differential equation, plus m into m plus 1, or I will say l into l plus 1, l into l plus 1 y, this is equal to 0. So the solution there in that case is given by, we have also obtained that very solution, that is always given by c0 x raised to power minus m minus 1 plus some m plus 1 m plus 2, then 2 into 2m minus 3, right? Then x raised to power minus m minus 3. If you go to the previous lecture, you will find out. So we have obtained this solution also. Now here we will take the C0 as constant to be equal to m factorial divided by 1, 3, 5, so on, 2m plus 1. Right, then this very differential equation we can write down the solution, this differential equation. So this, then if when we substitute c0 as given by this, then I can write down the solution as this qmx is given by, instead of c0 I will write m factorial divided by 1, 3, 5, so on up to 2m minus 1, 2m minus 1, then into x raised to power minus m minus 1 plus m plus 1 into m plus 2 divided by some 2 into 2m minus 3, then x raised to power minus m minus 3 plus some other terms, some higher order terms. And this polynomial is what we called as a Legendre polynomial of second kind. Polynomial of second. So one of the solution to your Legendre differential equation corresponding to r equal to m is called as a Legendre polynomial of first kind, and the other solution corresponding to the root equation r minus m minus 1, that is simply called as a Legendre polynomial of second kind. Provided we will just substitute the value for c naught in both the cases. In the first case as uh, c naught the value, and in the second case we will substitute the value of c naught as this, then we call them as a Legendre polynomial again. But this particular series, ये जो series है for corresponding qmx, this is non-terminating, or we can say the infinite series. So it will not terminate for any value, infinite series. So we won't be able to, we do not need to find out what will be the first term and what will be the last term. So now these are the two different solutions. Then I will say that the general solution to the Legendre differential equation is given in terms of these two solutions. So the general solution so the general solution to your Legendre differential equation, so the general solution to the Legendre equation is simply y will be equal to, because that is the differential equation is y is equal to some a pm of x plus b qm of x. Now you know that this a and b are two arbitrary constants. They are arbitrary constants. So this is the solution to your Legendre differential equation. I hope this is okay. If this is okay, then I will move to the okay.
सर
Yes.
जो आपने जनरल टर्म लिखी ना,
Hmm.
शायद 2 plus 3.
No, आवाज आपकी नहीं आ रही. I do not hear you.
सर जो 2 into 2m plus 3.
Sorry, आवाज तुम्हारी साइरिश नहीं आ रही है. हाँ, फिर
जी
से
सर
repeat करो.
जो जनरल सॉल्यूशन लिखा ना हमने,
Right.
उसका जो न्यूमरेटर है ना,
हाँ
2 into 2m plus 3 है वहाँ, इसके ऊपर जहाँ पे n के ऊपर टर्म है.
तुम्हारी आवाज कट करके आ रही है. यू मीन कि जो लास्ट लेक्चर में हमने जनरल सॉल्यूशन निकाला वहां पे 2m plus 3 आ रहा है.
जी सर वो 2 into 2m plus 3.
Is it so?
जी सर.
Okay, yes, you are right. So here we
जी
will.
सर और जो QM है ना उसमें भी है, उसमें 2m plus 1, वहाँ पर आपने 2m minus 1 लिखा है.
PM में. Yes, you are right.
जी सर वहाँ शायद 2m plus 1 है.
Okay, yes, you can correct it. Yes. This is 2m plus 1, this is 2m plus 1, 2m plus 3, so on and so forth. Similarly, here it is 2m plus 3. You just correct it yourself. Huh? यहाँ पे भी. Very good. Yes. Okay. So rest is okay?
जी सर.
Okay. Now, if it is okay, then see. Now I will try to obtain the few of the Legendre polynomials. Some of the Legendre polynomials I will try to obtain from this Legendre solution. right? Now since we find out since we find out this pm of x is given by the first solution में 2m minus 1 ही है, not plus. In the first solution there is 2m minus 1. Since this pmx is given by 1, 3, 5, so on, 2m minus 1 divided by m factorial, and then x raised to power m minus m into m minus 1 divided by sum 2. यहाँ पे 2m minus 1, then x raised to power m minus 2 plus some other terms, right? Now we will try to find out the various polynomials corresponding to different values of m. So if m is, I will consider this m to be as a non-negative integer starting from the 0. Now see, from this very equation, for m equal to 0, I will write down this as p0 of x. What is p0 of x? If you will substitute m is equal to 0 in this equation. Now see, there is a little confusion among the students, that you will find out that 2m minus 1, 20 minus 1, that will be minus 1 divided by 0 factorial is 1. 0 factorial is equal to 1. So it will be minus 1 into x raised power m. X raised power m is 0, so it will be 1. Then 1 into minus 1, it will be minus 1. But we are usually writing it by the plus 1. So the first polynomial p0 of 1 will be equal to 1, because now when you will plot it, you can take it minus 1 also, but then it will lie in the this lower quadrant. But usually you will see later on, we also try to find out these polynomials from a one formula that we call as a Rodriguez formula. So Rodriguez formula say hum this p0x comes out to be some constant, it is equal to 1. So again, now when m is equal to 1, so what will be this p1 of x? Now p1 of x will then be equal to, okay, this will be again, so we will have 2 minus 1, that is 1 divided by 1 factorial, it is 1, x raised power 1, it will simply be equal to x, right? Now this is 1 minus 1, it will become 0, they will, this will be, they will terminate. Okay, so okay, then corresponding to m equal to 2, what will be p2 of x? Now p2 of x will be 2 2s are 4, 4 minus 1 is 3, 3 by 2. So you can say that this is 3 by 2 into, now this is x square minus, okay, minus जरा इसको करो, this is 2, huh? This is 2 into 2 minus 1, that is 2 divided by 2 into 3, right? 2 into 3, 2 to 2 2s are 4 minus 1, that is 3, 2 into 3 into x raised power 0, 2 minus 2, that is x raised power 0, that is x raised power 0. Okay, so now you can write this as, so this is x raised power 0, that will make it 1, it will make it 1, x raised power 0 is 1, but we have a this constant here, so I will write down this as 1 by 2, this 3x square में यहाँ पे ले minus 2, right? No, sorry, minus 1. This 2 and 2 will cancel out here, minus 1. 1 by 2. It should be a 4 here, m into m plus 1. M plus 1. 3x square. Three x square minus, this is m into, okay, sorry, so this one, this is minus 1, this minus 1 by 2 is also multiplied to this term, this is multiplied to this term also, this 2 and 2 will get cancelled out, 1 by 2 will be equal to 3x square minus 1, so this will be, or simply you will say that, so this p2x will be equal to 3, sorry, 1 by 2 3x square minus 1, because this 1 by 2 is we are getting from here, right? Now similarly, for m equal to 3, now when you will substitute m equal to 3, it will be 2 3s are 6 minus 1, that is 5, 5 by 3 factorial, that is 6. So you will see that p3 of x will be equal to 1 by 6 5x cube minus 3x, right? And similarly for m equal to 4, you just give these values here in this, इसमें second term भी आप लिख लीजिए, or you will find out this. So p4 of x will be equal to now 1 by 8. You just do it yourself, you just substitute the values, because otherwise it will take time to obtain all these values here. 63 x raised power 5 minus 70 x cube minus plus 15x. Similarly, you can find out P5, P4, but just try to obtain up to the P4 because P5 will be little more complicated. Then you need to write down various terms here. So these are the different polynomials, Legendre polynomials of first kind. Now you can also plot these Legendre polynomials of first kind. Like I will just show you some of them, this polynomials on a graph. Now you can plot them like, for example, if this is an axis for me. So I'm taking this all as an interval. This is 0, this is 0.5, this is 1, this is minus 0.5 here, this is minus 1 here. Similarly, this is 0.5 but minus, and this is 1 point minus 1.0. Similarly, here this is 0.5 and this is 1. Right now, corresponding to your first this polynomial p0 of x, p0 of x is 1, p0 of x, so whatever the value we will obtain, the p0 of x is 1, it is constant. This is p0, right? Similarly, p1 of x is x, so it will increase as well as correspond to x and the minus x. So this will be the, you can plot, this will be the p1 of x, this p1. What is P2? Now P2, you can just plot it. This is some function. जैसे हम function लिखते हैं f of x is equal to x square. You can plot this function. So this function. Now you can just okay. So we can just have the P2 of x. So P2 of x will be like, P2 of x will be like this. It will go like this. P2 of x. P2 of x. Right? This is P2 of x. Similarly, I will have the P3 of x. P3 of x will be like, it will go from here. Now it will cross through this center, and then it will end up like this. Okay? So this will be the P3 of x. Similarly, we will have the P4. The P4 of x will be like, it will come from this very point, then it will go like this, then it will again pass through the, not the center this time, it will go like this and it will pass through this 0, then it will come out from 0 minus 0 point and it will go like this. So this particular function will be p4. It is also given on the book. You can just, अगर आपको यहाँ पे थोड़ा सा इसको, this is also given on the book Arifkin. Arifkin पे these Legendre polynomials आपकी plot किए हुए हैं. So these are the, similarly I will have the Legendre polynomials f5. So corresponding to different values of the x, I can plot these Legendre polynomials. So these are the different types of the Legendre polynomials which we obtain from this, from the very this na Legendre differential. Legendre differential equation, the solution to the Legendre differential equation, which we call them as a Legendre polynomial. So these are the different polynomials, and we call them as a polynomials of the first kind. We also have the polynomials of second kind, QM of x, but since that is an infinite series, so that is becomes little difficult to plot here. That will not end up here, and it's so we are not actually interested in those kind of things. Okay, so अभी जो मैं आपसे कह रहा था, this Legendre polynomial, now we can write down this Legendre polynomial as I was saying it for two different cases. So we can write this Pm of x as, this Pm of x can be written as, uh, it's given as summation sum r running from 0 to p minus 1 raised to power r, then 2m minus 2r factorial divided by 2 raised to power m, 2 raised to power r, sorry, 2 raised to power r factorial, m minus 2r factorial, and m minus r factorial. So this is the Legendre polynomial in general can be written, can be given by this very equation. So you, where this p is equal to m by 2 for the case if m is given, and so the summation is running from 0 to m by 2, and p is equal to 1 by 2 m minus 1 if m is odd. Okay, so we will have the summation, then for m equal to odd values we will have the summation will go from 0 to m minus 2. Let us suppose, for example, m is equal to here 5, sorry 4, yes 6, let us suppose 4. So the summation will go from 0 to 4, right? M by 2, so 0 to 2. So we will have, we can just have the values here in this particular, in this equation. So instead of writing all that very equation, all the other all different terms, you can write down. For let us suppose, let us try to do it for a one term here. For example, we have r is equal to, sorry, this m is equal to 4 or m is equal to 2. Let us suppose m is equal to 2. So this particular differential equation, sorry, this particular Legendre polynomial will now become summation r running from 0 to m is p is equal to m by 2. So m by 2 is m is 2. So it will be 2 by 2, that is 1. So summation r will run from -1 to r. Okay, so the summation, instead of summation, we will have the only one term now. So it will be -1 raised to power r, 2m minus 2r. Just give the values to this value. 2 2s are 4 minus, and r values we can just substitute. R is the value that can take 0 and 1. So I will take the value 0 and 1. So we can find out those polynomials जो हमने अभी मिले थे. We can also obtain this these polynomials. We can obtain this series. So we can have this particular series for different values of r. We will not have this for the r. For the first case, we will have only the, for example, m is equal to 1, we will have only x term, one term. For m is equal to 2, we will have these two terms. Agar for example yahi m, for m equal to 2 ab karoge, you will get two terms in this equation. You will get here in this equation, you will get two different terms for this very part. Is it okay? Okay. So now, if it is okay, then I am just I will just move to the next part, but I will wait for few minutes because I want you to rejoin it for the another meeting, because this meeting is going to end in some 5 minutes. Okay. So till then, if you have some questions or some queries, you can ask. If you have some anything to ask, you can.